Today, we're plunging into the fascinating, sometimes frankly terrifying, world of a disease that has truly shaped human history. It's carved deep into our cultural memory and even left its mark on our biology. It's often misunderstood, and maybe most surprisingly, it's still very much with us. We're talking about the plague caused by that notorious bacterium, Yersinia pestis.
That's right. So our mission today is really to sift through these, pull out the most critical and honestly the most interesting bits of knowledge, give you a shortcut to being, really well informed.
Exactly. We want to cut through some of the myths and get to what's really crucial. We'll explore its different clinical forms, how it actually spreads, which might surprise you a bit.
Yeah, there are some twists there.
Our modern understanding, diagnosis, treatment, and its ongoing impact. Okay, let's dig in. So when most of us hear the plague, we probably picture one particular grim scenario. But here's a key detail that often gets missed. The same tiny culprit, Yersinia pestis, can cause 3 really distinct clinical forms, different symptoms, different dangers.
And it's this variety that makes understanding it so challenging, historically and even now. The most common form is bubonic plague.
Okay.
This is typically what happens after a flea bite or maybe handling an infected animal. The bacteria get into your lymphatic system, and they cause this severe inflammation of the lymph nodes, what we call acute lymphadenitis.
And those are the famous buboes, right? Those incredibly swollen, painful glands.
Exactly. The name bubo actually comes from a Greek word for groin or swollen gland. Autopsies show they're often hemorrhagic or necrotic, basically filled with blood or, dead tissue. It is. And what's particularly clever, biologically speaking, about why pestis is that it can reproduce inside your own cells. Even after immune cells, phagocytes, have engulfed them. It's quite resilient.
Wow.
So if those lymph nodes get overwhelmed, the infection can spread further. It can become secondary septicemic plague or potentially even secondary pneumonic plague.
Okay, so bubonic targets the lymph system primarily. What about when Y. pestis gets straight into the bloodstream? That sounds, much worse.
It generally is. That's septicemic plague. This happens when the bacteria just multiply in the blood, spreading everywhere. The bacterial endotoxins can trigger something called DIC, disseminated intravascular coagulation.
Ah, DIC.
Right. Your clotting system basically goes haywire. You get tiny clots blocking small vessels all over. This leads to ischemic necrosis tissues dying from lack of blood. And you get bleeding into the skin, organs, often causing that characteristic red or black patchy rash. Untreated septicemic plague is usually fatal. But, and this is key with quick antibiotic treatment, mortality drops dramatically from maybe 70% overall without treatment down to somewhere between 4 and 15%.
That's a huge difference. Modern medicine really changed the game there. But you mentioned pneumonic plague. That one always sounds the most frightening. What makes it so dangerous?
You're right to flag it as especially dangerous. Pneumonic plague is the lung infection. And what really sets it apart and made it so devastating historically is how infectious it is.
Cool.
It's highly contagious. It spreads directly, person to person, through airborne droplets when someone infected coughs. Symptoms often start with headache, weakness, then coughing, chest pain, maybe even coughing up blood. Though importantly, initial signs can look like any other respiratory illness.
So it could easily be missed early on, mistaken for flu or just bad pneumonia?
Precisely, which makes rapid diagnosis critical. And the incubation period is incredibly short, usually 2 to 4 days, sometimes just hours.
Hours? Wow.
Yeah. The disease progresses very fast, often fatal within 1 to 6 days unless treated very, very quickly. Untreated pneumonic plague has a mortality rate near 100%.
Just devastating.
It really shows the adaptability of this one bacterium, doesn't it? How it can present so differently. It's why vigilance is still so important today.
Absolutely. That's a chilling picture of the disease itself. But the story of how it spreads. Well, for centuries, that narrative was pretty simple, almost too simple. Let's get into the surprising reality there.
Yeah.
For so long, it was all about rats, right? But there's a really interesting twist.
There is. The common understanding isn't wrong, exactly, just incomplete. It's true, Yersinia pestis circulates in animal reservoirs, mostly rodents. You find these natural foci on all continents except Australia, roughly between 55 north and 40 south latitude.
Okay.
And the main vector is the oriental red flea, Xenopsilochiapis.
The mechanism is fascinating, actually. The bacteria multiply inside the flea's gut and form a blockage, a plug.
So the flea is essentially starving. It bites a host repeatedly, trying to feed, but because of the blockage, it just regurgitates blood mixed with bacteria back into the bite wound.
So the fleas are the direct transmitters, not really the rats themselves. That kind of makes the rats victims too, doesn't it?
Exactly. That's a key point often missed. Rodents are frequently the first victims. The plague hits their population, they die off.
And then the infected fleas need a new meal.
Precisely. They leave the dead or dying rodents and seek other hosts, which can include humans nearby. So those images of medieval rat catchers. Important, sure, but maybe focusing on only part of the picture.
Okay, but here's where it gets really fascinating for me, looking at the more recent research. A 21st century study looked at that famous 1665 plague outbreak in Eyam, the village in England that isolated itself.
Ah, yes, the Eyam study. Very important.
They found that something like 75% of the cases were likely due to human transmission, especially within families. That's way more than previously thought.
It really shifts the perspective, doesn't it? It highlights how much direct human contact and, well, human parasites mattered. Newer research also suggests that human fleas and body lice played a significant role too, not just rat fleas.
Human fleas and lice?
Yeah.
Seriously?
They could have potentially spread the disease even faster in some circumstances than rodent fleas. So it's not just a simple rat-flea-human chain. It's a more complex web. Droplet contact for pneumonic, direct physical contact, maybe contaminated surfaces, our own parasites.
So the bottom line is, plague transmission is more complicated and, frankly, more directly human-centric than the old story suggests. It really makes you rethink how we've understood these historical pandemics, doesn't it? Our living conditions, social structures.
Absolutely. How close people lived, hygiene. It all likely played a bigger role than just the rat population alone.
Okay, so despite that terrifying history and complex spread, we have come an incredibly long way in fighting plague. From a medical standpoint, what does diagnosis and treatment look like today?
Well, the good news is, modern medicine has really transformed the outlook.
Yeah.
But because those initial symptoms can be vague, lab testing is absolutely crucial for a definitive diagnosis.
Right. You can't just guess based on symptoms alone.
Exactly. The gold standard is identifying Yersinia pestis directly, microscopy and culturing samples from blood, sputum, or aspirating fluid from a bubo. But there's a catch.
Okay.
As clinicians, we know that if antibiotics were started before the sample was taken, or if the sample isn't handled perfectly, you can get false negatives on the culture.
Ah, right. The antibiotics might kill the bacteria in the sample, so how do we deal with that?
That's where molecular methods are so valuable. PCR polymerase chain reaction. It detects the bacterial genes like Play or CAF1, even from tiny samples. And crucially, PCR works on dead bacteria too.
Oh, that's clever. So even if antibiotics were started, PCR could still pick it up.
Precisely. It gives us vital information. We also have rapid diagnostic tests now, like F1 RDTs. They detect a specific antigen, the F1 capsule protein, on the bacterium surface.
Quicker results then.
Much quicker, yes. Really useful for suspected pneumonic or bubonic cases to guide immediate treatment and public health action. But you still need to be careful. Both positive and negative rapid results ideally need confirmation and should be interpreted considering the whole clinical and epidemiological picture. False positives can happen.
Makes sense. It's amazing, though, how early diagnosis changes everything. If caught in time, plague is highly treatable with antibiotics, isn't it?
Absolutely. It's gone from a near-certain death sentence to a manageable condition, if treated promptly. Standard antibiotics like streptomycin, chloramphenicol, tetracycline work well. Newer options like gentamicin and doxycycline are also effective, even as single drug therapy.
But are there concerns about resistance? That's always a worry with bacteria.
It is, and unfortunately, yes. Drug-resistant strains have been identified. There were notable instances in Madagascar during outbreaks in 95, 2014, and 2017. It's a serious concern, underscores the need for ongoing surveillance. Antimicrobial resistance is a constant battle.
A sobering reminder. What about prevention? Is there a vaccine?
There is a history there. Waldemar Hafkeen developed the first plague vaccine back in 1897, which dramatically cut mortality rates, especially in places like British India. But today, routine vaccination isn't recommended for most people.
Because it's relatively rare globally now.
Exactly. It's generally only advised for high-risk groups. Lab workers dealing with potentially resistant strains, people involved in aerosol experiments, maybe field personnel in areas where plague is endemic and exposure is hard to avoid. Really early diagnosis is the most critical prevention tool for stopping spread.
And what about taking antibiotics preventatively? Say, if you've been exposed.
We call that prophylaxis. Pre-exposure prophylaxis generally isn't needed for healthcare workers or first responders if they're using standard and droplet precautions properly. Maybe in a crisis like mask shortages, you might consider it.
Okay.
But post-exposure prophylaxis, that is recommended for close contacts, think less than 6 feet, sustained contact with a pneumonic plague patient, especially without proper PPE. Also for lab accidents, or people like vets or hunters who've had close contact with infected animals.
It's just incredible, the progress. From the Black Death to antibiotics and PCR, a completely different world.
It truly is. Vigilant public health and effective treatments have largely tamed it.
Okay, let's broaden out now. Because the plague didn't just kill people, its legacy is immense. It reshaped societies, inspired culture, and disturbingly, even became a weapon.
That's right. The impact goes far beyond the medical charts. The Black Death in the 14th century, which killed up to half of Europe's population, maybe over 50 million people, that was just one of at least 3 major plague pandemics. There were huge ones in the 6th and 19th centuries, too.
Each leaving a massive mark, I imagine.
Absolutely. After the Black Death, for instance, the massive labor shortages gave surviving peasants way more bargaining power. It actually contributed to the decline of feudalism in Europe.
Wow, an unintended socioeconomic consequence.
And fascinatingly, modern DNA tech has traced the origins of that 14th century Y. pestis strain to human remains found in Kyrgyzstan, dating from 1338-1339.
Really? A potential ground zero.
It looks like a strong candidate for where it jumped from animals, likely local marmots, into humans. The strains found in marmots there today are its closest known relatives.
Incredible detective work. And the plague's shadow lingers culturally too, right? Like that nursery rhyme?
Ring around the rosy.
Yeah.
Yes, there's that popular link, though historians debate it. The rosy rash, the pocket full of posies to ward off the smell or miasma, the ashes or a tissue sneezing in, we all fall down.
Def.
Right. Whether it's historically accurate or not, the fact that the connection exists shows how deeply plague embedded itself in collective memory.
But there's a much darker side to that legacy too. Its use as a biological weapon.
Yes, a truly disturbing history there. It goes way back. Ancient China and medieval Europe reports of using infected animal carcasses, even human bodies, to poison wells or catapulting them into besieged cities.
Like the Mongols at Kaffa.
Exactly. The Siege of Kaffa in 1346 is a famous, though debated, example. Some think that act helped accelerate the plague spread into Europe. And it didn't stop there. World War II saw horrific use by Japanese Unit 731.
Unit 731, yes.
They deliberately infected Chinese, Korean, Manchurian civilians, POWs, studying the disease. Shiro Ishii, the unit's head, even developed ceramic bombs specifically designed to disperse plague-infected fleas without killing them in the blast.
That's chillingly sophisticated evil.
It is. And after the war, both the US and the Soviet Union developed weaponized pneumonic plague. They experimented with delivery systems, antibiotic-resistant strains, even genetic engineering. Aerosolized pneumonic plague is still considered a significant bioterrorism threat.
But there are countermeasures now.
Thankfully, yes. Some countries, like the US, maintain large stockpiles of antibiotics, specifically to counter biological attacks like weaponized plague. So the threat, while real, is perhaps less severe than it might otherwise be. Preparedness helps.
It's hard to believe after all that history, but the plague hasn't actually disappeared, has it?
Not at all. It still exists. Globally, there are around 600 or so cases reported each year, mostly in places like the Democratic Republic of Congo, Madagascar, Peru, and even some rural areas in the US, particularly the Southwest.
Still out there in animal reservoirs.
Exactly. It's not gone, it's just, as we said, largely tamed by modern medicine and public health. And maybe one of the most profound parts of its legacy is genetic.
How so?
Survivors of past pandemics, the ones with immune systems slightly better equipped to fight off Y. pestis, pass those traits on. So there are literally traces of plague resistance woven into the DNA of modern populations. These adaptations might even influence our susceptibility to other unrelated diseases today.
So its mark is not just in history books, but literally inside us.
Pretty much, yeah, an indelible mark.
So wrapping this up, what does this all mean for you listening to this? We've really gone deep into the plague, its bacterial roots, the different ways it affects the body, its complex spread, the devastating history, and how we fight it today.
It's a journey from this ancient, terrifying scourge to something that, while still present, is now largely treatable.
But it's still a powerful reminder, isn't it?
Definitely. A reminder of how linked our health is to our environment, our history, the animal world. It shows that delicate balance, even now.
Absolutely. And, thinking about that genetic legacy you mentioned, the idea that the plague's fingerprints are literally in us, shaping our immune systems, that really stuck with me.
Oh,
It
yeah.
makes you wonder, doesn't it? What other hidden legacies might ancient diseases have left behind in our bodies? How might they be subtly influencing our health, our susceptibility to modern illnesses, in ways we're only just starting to figure out?
That's a fascinating question. What echoes of the past are still playing out in our biology today?
Exactly. Something for all of us to maybe ponder. What else is hidden in our history and in ourselves?